All right, today we're going to talk about 7.8 single variable subtraction equations. So we are going to look at subtraction is going to be our key focus here. Let me grab another color so I'm ready. All right, we're going to again remind ourselves that our goal is to isolate our variables. And in this case, if I write three examples, we could certainly say that this is isolated, this is isolated, and this is not. Simply because our goal is to keep our variable on one side with all of our other stuff on the other. All right, so in this case, we're going to be looking at subtraction problems. Let's take a quick example. And our example is going to be a minus 15 equals 18. All right, in this one, we're going to be using a similar property that we used before. This time it's going to be called the addition property of equality. And I can probably fit it up here. Addition property of equality. And just like before, it goes like this. If A equals B, then A plus C equals B plus C. So what this is really showing me is if I have two numbers that are equal, I can add the same number to both and they will stay equal. So just like before, if I add something to one side of my equation, I need to add it to the other side of my equation. That's simply all this is saying. Okay, so let's look at this one, and we need to do some isolating, and we're going to write down every step as we go. All right, so I have a minus 15 by my a, so I'm just going to add 15. I have a minus 15 plus 15. Now, if I add 15 to this side, I'm going to have to add 15 to the other side. 18 plus 15. All right. Then if I'm going to really simplify it, a minus 15 plus 15, going to get a plus 0, and I can just get rid of that plus 0, and I have a equals. I had equals before as well. And 15 plus 18, I can simplify that to 33, I hope. And that's going to give me a equals 33. And this is how I'm going to be solving all of these problems. Just like this, using my addition property of equality. I'll probably do two examples just like we did last time. Okay, let's look at example 1. In this case, we have Harry, and he earned $19.50 this week. And that is $6.50 less than the week before. Ooh, didn't get as many hours. Maybe didn't babysit as much. I don't know. So we're going to set up an equation, and then we're going to solve it. So M equals money earned. All right, so he earned $19.50. And last week, he earned M is going to be our money earned last week because we don't know it. That's what we're trying to figure out. This is how much he earned this week. Last week, he earned, the amount that he earned last week minus $6.50. Because last week he earned this much, and he earned the money he earned this week is less than the week he did before. So I can write this as M minus $6.50 equals $19.50. And I'm going to use my same problem that I did before, my same process. I'm going to just add $6.50. which gives me m isolated. Now, it doesn't have to be on the left side. It can be on either side. It doesn't really matter. And 1950 plus 650 should be $26. That's how much he earned last week. Okay? Let's take a look at another quicker and simpler example before I send you on. Solve for x. Got x minus 44 equals 22. Okay, pretty simple. Oops, I hope I wasn't off the page that whole time. I think I might have been, sorry. Let's solve it. X minus 44 plus 44 equals 22. Since I added 44 to this side, I'm going to add 44 to this side. X equals 66. Go ahead and go on if you understand. I'll do one quick more if you don't. Our next one looks like this. X minus 1.3 equals 5.6. Okay, I'm going to add my next step. X minus 1.3 plus 1.3 equals 5.6. I need to add this as well, 1.3, because I added it onto both sides. I have x, 5.6, and 1.3 is 6.9. And we are done. Nice.